Hi children, today we are going to discuss some past paper questions on functions. All the theories related to functions I have discussed in my previous videos. You can watch them, I have listed them below. If you have still not subscribed to my channel, please do so now and press the bell button also so that you can get all my new videos as soon as I upload them. Children, please note that all these questions are taken from Cambridge P1 papers, that is 9709 papers, all the P1 papers. Right, let's see this February-March 2021 question. Now here we've got two diagrams you can see. This is the original graph, this is a transformed graph. In the question we are supposed to recognize transformation, right? We will look at this carefully now. See, there is an enlargement here because this is just 1 unit when it comes to this 3 units, right? There is a scalar factor of 3, right? And then it is this is the enlargement, right? You can see it. This enlarged figure is translated along the x-axis horizontally by how many points? 1, 2, 3, 4 points, right? By 4 points. This is from here to here by 4 points. Okay. Therefore, next transformation is a horizontal transformation, right? The equation of this one will be this 3 times x minus, this is asked in the next part of the question, right? Now if you verbally describe this transformation, it's a translation of fx along the positive x-axis direction by 4 points and an enlargement by a scalar factor of 3. As an equation they want it here in this, right? So this is the answer. We are multiplying by 3 because it's enlargement. Because of the translation x minus 4, translation is in the positive x direction, therefore minus 4. If it is negative x direction, it would have been plus 4, right? Here what we want is minus 4, right? I think you understood it. What is the next question? Function, this is also February-March 2021, same CIE paper. Fx is equal to x squared plus 2x plus 3. The domain is x is less than or equal to minus 1. Then gx is defined as 2x plus 1. Here the domain is x is greater than or equal to minus 1. Here x is less than or equal to minus 1. Here x is greater than or equal to minus 1. These two are very important. Please keep it in mind, right? We will be using this in the next parts of the sum. Express fx in the form of x plus a squared plus b and state the range of f. Here what is to be done? Here this is completing square. This is a very simple case, right? We will see step by step how do we do this completing square and take this answer. Step number 1, we just wrote it here, and then we take half of the coefficient of x, that is 1, square it and then subtract. When you square it, it is 1 itself, right? Half is squared 1 itself, and then minus 1 plus 3. You add then subtract. You take half of the coefficient of x. How much is the half of the coefficient of this x? 1. You square it. When you square 1, it is 1 itself. Add then subtract. You can't just do one thing. If you added, you have to subtract to nullify it. Now we will take these first three terms and then we can write it as a square. Right? We can write these three terms as x plus 1 squared. If you have any doubt, you expand this and see, then you will get this one. Then we can simplify these two terms, minus 1 plus 3. Minus 1 plus 3 is plus 2. Right? Now this is the this format of this sum. Then here a is equal to plus 1, b is equal to plus 2. Right? Now the range of this fx means the fx values. So this is always greater than or equal to 2. When you apply x equals minus 1, this will be vanished. Right? Then fx is equal to 2 in that case. But for any other value of x, this is a positive number because of this square. Then something will always be added to this. So minimum value is 2. It is always greater than or equal to 2. Therefore, we can say fx is greater than or equal to 2. This is the range. The set of values of fx is the range. So fx will always take values greater than or equal to 2. This is the range. Okay. Right. We have answered the first part. Then we have to find an expression for f inverse x. We'll move on and see. Right. How do you find the f inverse x? We write this fx as y first. I have explained this very well with lot of examples in my videos on theory. So you can refer to them also. Now we will make x the subject. First of all, take 2 to this side. Y minus 2 is equal to x plus 1 squared. And then we take the square root in order to isolate x. So plus or minus square root of y minus 2 is equal to x plus 1. And then we take this one also to this side. So you can say x is equal to, when this 1 goes to the other side, minus 1 plus or minus square root of y minus 2. So now we got to discard either plus or minus, right? One of them has to be discarded and select one. We will see what is to be selected here. Now this is the range of the f inverse x will be same as the domain of the fx. Domain of fx is x is less than or equal to minus 1. Earlier I told you to remember it, right? So now fx, all these fx values should be less than minus 1. So if you take plus here, it will not be less than minus 1. So therefore we choose minus 1 here, right? Because our f inverse x should be less than or equal to minus 1. The reason is the domain of fx is less than or equal to minus 1, right? The domain of fx will become the range of f inverse x and vice versa. Okay. Therefore we can say x is greater than 2, greater than or equal to 2, and f inverse x is less than or equal to minus 1. And then next part of the question, they want us to take the g inverse x, gfx. They want us to take gfx. So in the function g we apply f, right? So in the function g we apply f. G is 2x plus 1. Wherever you find x here, we apply the whole f function in this place. So then this will become g x squared plus 2. So 2 times x squared plus 2 plus 1. So you can open this bracket, 2x squared plus 5. So g of x is 2x plus 1 squared plus 5, right? This is g of x, that is what they wanted. Let's move on. And they have given g of x is equal to 13. We are supposed to find the x's which at this point. So g of x is 2x plus 2 squared plus 5 equals 13, and then 2x plus 2 squared is equal to 13 minus 5. Then 13 minus 5 is 8. 2x plus 2 squared is equal to 8, and then you divide both sides by 2 and then take 4 here. X plus 1 squared is equal to 4, and then x plus 1 is equal to plus or minus 2. So x plus 1 is equal to plus 2, or x plus 1 is equal to minus 2, and then x equals 1, or x equals minus 3, right? Our x should be less than minus 1, right? Therefore we choose the answer x equals minus 3 here. Both the answers cannot be taken because one will violate this condition. This is a special situation, right? So we got to be very careful when they have restricted the domain, right? If the domain was full R for both, then no problem, we can take both these answers. But here they have restricted the domain, so we have to find these answers which are tallying with that or will not violate that condition. Okay, so this is the right. This is October-November 2020. Functions f and g are defined by fx equals x squared plus 3, x is greater than 0, gx is 2x plus 1, x is greater than minus half. Note the fact that equality is not there. Remember these two domains, and if you just have an idea about the range of this fx, it is greater than 3, range of this one is greater than 0. Just keep it in mind when you read a function. It is always better to store in your head what is its domain and range at once. Make it a habit. Now we are supposed to find an expression for f of gx. Then what we do is we substitute inside f the function g. We will look at the steps here. F of gx, that means in the function f we apply g, right? Wherever you find x, you apply whole g function there, that means 2x plus 1. So 2x plus 1 squared plus 3. This x is replaced by this function, right? Now the range of this function will be greater than or equal to 3. Next part of the question, we are supposed to find inverse of fg, right? We will look at it. Inverse of fg, fgx is this. Then what do we do? Our typical procedure of finding the inverse of a function is to replace this by y and make x the subject. You look at it, y is equal to this much, and then y minus 3 is equal to 2x plus 1 squared. What we did was we took this plus 3 to the left hand side, when it goes to the left hand side it goes as minus 3, right? Now we have to isolate x, so this has to be first of all taken to the other side. This square goes to the other side as a square root. We take the square root on either side, and then we have 2x plus 1 is equal to plus or minus square root of y minus 3. When we take the square root, it is a must to apply plus or minus. Then we can say 2x is equal to 1 plus or minus y minus 3 root, and then fg inverse is equal to, this is divided by 2 either side, and y is replaced by x. Now here there is plus and minus. Here there is only plus. Why we took only plus instead of minus, right? Now the domain of this function, domain of f function, is greater than minus half. Therefore we take the positive side. Okay. Now next part of the question, you have to find g f x as well, because f g x minus 3 is equal to g f x. We have to solve this equation. Now we look at this. G f x is equal to this. In the function g, you apply f, right? 2 times x squared plus 3 plus 1, right? Then this is 2x squared plus 7. Now we have to solve this equation. Fgx minus 3 equals gfx. Fgx we found in the previous part of the question, right? Now we have to apply it in this and solve. So fgx is 2x plus 1 squared plus 3, and there is a minus 3 here, and then gfx is 2x squared plus 7. Then we will be left with this. So in order to solve this equation, we have to expand this side and take similar terms to one side, all terms to one side, and then factorize it. I hope we'll see. We'll expand this first, right? When you expand this, it will become 4x squared plus 4x plus 1. On this side you have 2x squared plus 7. Then what do we do? Just tell me. Yeah, you take these terms to this side. Okay, so when this 2x squared goes to the other side, how does it go? As minus 2x squared. When this 7 goes to the other side, it goes as, yes, minus 6. Then we will write it. When this one goes to this side, minus 2x squared, then 4x squared minus 2x squared is plus 2x squared. This is 4x squared. This is plus 1. When this comes to this side, there is minus 7. Plus 1 minus 7 is minus 6. Now this 2 is common for all. We'll divide everything by 2. So it's a simple quadratic equation now. 2x squared plus 2x plus 3 minus 3. Then you can very easily factorize this as x plus 3 x minus 1. Then we'll have the answers. X is x minus 1 equals 0, x plus 3 is equal to 0, and then x is equal to 1 or x is equal to minus 3. But this minus 3 is not possible for us to take as the answer, because our x is always greater than 0 and greater than minus half. So this is not in this domain. Therefore, we will have to discard this answer and take the answer x equals 1. Now, these concepts, what is domain, what is range, what is inverse, these concepts you got to clearly understand. Now, you can't answer the present day questions mechanically without understanding the concept. Now, even in this case, most of the students would tend to give this also as an answer, but you should be very careful, because this is, if you have not understood this domain concept clearly, blindfoldly you come here and say, and you never think of these things. When you are giving answers for the functions questions, you got to be very mindful about what is the domain of this function, what is the range of this function, right? Because some values cannot be taken if there are restrictions for the domain. So you got to be very careful here. Present day, most of the examiners are trying to test how much the students have comprehended the thing, not a set of by-hearted steps. Now these steps most of the students by heart, first this, first that. It is not the thing. We have to understand the concept. That is the beauty of mathematics. Okay, we'll move on to the next question. Now this question is, of course, when you look at it, you can see it is safe, because here the domain is x belongs to R and range also x belongs to R. Here domain is x belongs to R and x is not equal to -1 because of this condition. Denominator cannot be 0. I have explained these things in my theory videos very well. And then here the range is also same, right? X belongs to R. Now so this is little bit less to think. It's a typical question. Now look at this. We have to find fg7. First of all, we will find the fgx and then apply the value 7. Some others might do in this way also. We will first find a g7 and then apply it in this. For the safe side, we will do fg first and then apply 7, because in this case only this, but in some other questions we have to use the fgx expression also. So always first learn to find fg. In the function f, you apply g 4 over x plus 1, then we can say 4 into 4, f is 4x, instead of this x we apply this 4 into 4x plus 1 minus 2, right? Now we can apply 7 here, right? 16 x plus 6 1 minus 2. Then we will apply x equals 7 here. This will be 2 minus 2 is 0. So fg7 is equal to 0. Now we have to find f inverse x and g inverse x and then equate them and solve this. This is a very easy typical question. F inverse x is equal to this, we will say y, right, and then y plus 2 for x is, f inverse x is equal to x plus 2 over 4. This is, I didn't explain much because these are very easy typical steps, right? Then g inverse also something similar to that. We make this y and then take this to this side, y times this, and make x the subject. So x plus 1 4 over y, x is equal to 4 over y minus 1, therefore g inverse x is equal to 4. Now we have found established our f inverse x and g inverse x. Now we will go to give it to this condition and then solve it. Right? What we can do is we can multiply the whole big equation by 4x, 4 into x. Then what we will do is this is taken to this side, this is taken to this side. 4x multiplying by 4x is that, right? X into x plus 2 plus 4 into x minus 4 minus x. So x squared plus 2x, 16 minus 4x. This goes to this side, dash plus 6, right? Then this is this. So we can factorize this very easily. X plus 8 and x minus 2. X equals minus 8. O x equals